Today we are going to see what is mass and what is weight. All of us must have heard these terms right from our school age, from 6th standard or 7th standard. But still, most of us have some doubts about what is mass and what is weight now and then, and their units. So let us see what each of these definitions are, and let us see the differences between mass and weight. So mass is commonly measured in kilograms and grams. Weight is commonly measured in newtons. So kgf 1 kgf is equal to 9.8 newton. Kilogram is a unit of mass and not a force. Convert to newtons. See, here we are going to convert a kilogram, 85 kilograms into newton. Suppose if they are asking us to convert a mass into weight, we have to use this. So W is equal to 85 kg, that is mass, into 9.8 meter per second square, that is acceleration, is equal to 833 newton. So that is called as weight. So unit of newton is kg meter per second square. Okay, that is F is equal to ma. F is the unit of force is newton, m is unit of m is kilogram, the unit of acceleration is meter per second square. So kgf is equal to kilogram force, which is called as kilogram force, which is equal to 9.8 newton. Weight is commonly measured in newton, that is 1 newton is equal to 1 kg meter per second square. So converting newton to kilogram force, that is 833 newton is equal to 833 divided by 9.8 is equal to 85 kilogram force. So that is, suppose we are converting 85 kg, that is mass, into weight, and that is into newton. Suppose if the value is given in newton, that is in weight, suppose if they ask us to convert it into mass, then we have to use 833 newton divided by 9.8, that is around 85 kg. Here, matter is anything that has mass and volume. Volume, when we say volume, which means which occupies space. For example, a car could be said to be made up of matter, as it has mass and volume. Okay, the car has nearly more than 200 or 300 components. Okay, seats, it occupies a lot of space for us to sit inside. It has that is matter means it has some solid objects like tires. It has lot of solid objects like tires, steering wheels, interiors, etc. So, and also it has some empty space inside for us to sit. So all this includes mass, and volume includes matter. The 7 states of matter are solid, liquid, gases, ionized plasma, quark-gluon plasma, Bose-Einstein condensate, and fermionic condensate. So normally we see only solid, liquid and gases, but apart from this there are so many other states of matter. So first let us stick to it, solid, liquid and gases alone for this video. So solid, we know salt, examples salt, wood, phone, cloth, etc. Liquid, water, mercury, blood, soda, coffee. Gas, air, carbon dioxide, helium, neon, helium, oxygen, propane. Plasma does not have any shape. Example is lightning, neon signs, suns, stars, etc. And also solid holds its shape, exact shape, whereas liquid conforms to the shape of the container, whereas gas also does not have any distinct shape, and plasma also does not have any distinct shape. So next we will come to weight. W is equal to mg, that is weight of the object is equal to mass of the object into acceleration. So, suppose here, like we have seen in the previous slide, we have to find, if we have to find out mass, that is the weight is 490 newton, we divide it by 9.8, we get 50 kg. Mass is the amount of matter in a material, while weight is a measure of how the force of gravity acts upon the mass. So observe this word, how the force of gravity acts upon the mass. So the weight is another word for the force of gravity. So in this difference between mass and weight, next difference we will see is mass is a scalar quantity and it has magnitude. Okay, that is length. When you are saying magnitude, that the meaning is length. Weight is a vector quantity. It has magnitude and direction, that is length and direction, and it is directed towards the center of the earth or other gravity well. Okay, see here you observe in mass we have only length or magnitude. Here you have magnitude as well as it has some direction. Okay, so that's what they are saying about difference between mass and weight. The next difference between mass and weight is your weight on the moon is 16.5% of what you have experienced on earth. In other words, if you weigh 100 kg on earth, you would weigh a mere 16.5 kg on the moon. I hope this is very clear. Okay, so in the moon you will be weighing very less, just 16.5% of what you are weighing on earth. So only when the situation comes where gravity is taken into consideration or gravity plays a role, we have to use the word weight. That is the reason we use the term mass and weight interchangeably now on earth for a normal usage. Only when we go to outer space or when we move beyond the earth, above the earth, then the play of G comes into picture. Mass does not vary with location. Okay, see here the mass is on earth is 10 kg, weight scale shows 10 kg, so weight is 98 Newton. On the moon the mass is 10 kg, weight scale is 1.6 kg and weight is 16 Newton. On space, okay, that is the in between the that is beyond the moon or empty space. Okay, on space mass is equal to 10 kg, weight scale is 0 and so the weight is 0. So in the space, when somebody asks what is the weight of a ball or something like that of a human body of 100 kg in a space, you have to mention as 0. So when we are talking about mass, there are two types of classifications in the mass, that is inertial mass and gravitational mass. Let us see each of these. Inertial mass is determined by how much the object resists the acceleration. Inertial mass is determined by how much the object resists the acceleration. When you are saying acceleration, it is the ability to move or accelerate from the current state. Okay, so inertia is the tendency to do nothing or to remain unchanged. Okay, when we are pushing a block of objects, see here, see a man here in his diagram is trying to give a force and is trying to push a cart which has some weight or mass, okay, in a particular direction. Suppose the amount of inertia depends upon the wheel here, the type of roughness of the wheel or smoothness of the wheel here. So that's what they call as a inertia. It is a tendency to do nothing or to remain or oppose the movement or acceleration. Inertial mass is measured under any force. A 9.8 Newton per kg is the force applied by gravity on a 1 kg of mass. The acceleration due to gravity is usually given by a value of 9.8 meter per second square. The gravitational strength on the surface of the earth is 9.8 Newton per kg, okay, or 9.8 meter per second square. So when measured when the object is in motion due to the applied force, if you apply more force on an object, it accelerates at a higher rate. So the inertia is a property of a matter by which it continues in its existing state of rest or uniform motion in a straight line unless the state is changed by an external force. I think this is very clear. Okay, now we will see. So gravitational mass. Gravitational mass is a measurement of how much gravity an object exerts on other objects. Okay, so gravitational mass is measured under gravity. The inertial mass is found by applying a known force to an unknown mass. So here the man is applying some force to an unknown mass or unknown mass. Okay, the measure, whereas here the force is applied in terms of gravitational force. Whereas in case of inertial mass, the humans have to give some force, whereas in the case of gravitational mass, there is no human involvement, whereas the nature plays that role, that is through G. That is F is equal to ma. When we have to measure the mass, m is equal to F by A we are using. Measured when the object, that is gravitational mass, is measured when the object is in motion due to gravitational force. Uses Newton's law of gravitation. So gravitational mass concept uses Newton's law of gravitation. Okay, whereas inertial mass uses the force applied through humans.